Well, hello and welcome to our Tech Talk on file-based modules. I'm Roslyn, a dev here at LabKey, and as Corey said, he is also a LabKey developer here. I'll be taking us through the bulk of the presentation today. And as he mentioned, once I'm out of breath and it's time for questions, Corey will be jumping in as well for answers. So let's get started. We're going to be going over the prerequisites for understanding the contents of this presentation, followed by an overview of what a module is and what benefits there are to using one. We'll also discuss the structure and file anatomy of a module before we jump into our demo. In the demo section, I'll be going over a file-based module that's publicly hosted on GitHub that we've put together for the purposes of this presentation. The module is intended to be self-documenting and an easy template of sorts to reference if and when you're looking to do file-based module development. Within the demo, we'll be covering creating custom web pages and LabKey web parts, file-based queries and R reports, and full page style control and customization. Afterwards, we'll discuss development and deployment processes for both on-prem and hosted servers. Then we'll discuss some advanced topics that are not implemented in the demo module, including what other types of module that are not file-based are out there. Then there will be a slide of relevant doc links and wrap up, after which it'll be time for questions. Please note down questions that may pop up. You can submit them via the Zoom chat while I am presenting. The recording of this Tech Talk will also be available, and the doc links will be sent out via email as well. So, prerequisites. To exercise for yourself the topics and concepts in this presentation, it'd be beneficial to already have a LabKey development machine. This will provide the groundwork of familiarity with LabKey Server that we will assume that we have here. But if you're not a developer yourself, this presentation will still be helpful in that it will cover from the functional perspective the capabilities of file-based modules. We will be showing HTML, XML, and JavaScript code during the demo section though, just so you're forewarned. But that's it. We'll cover modules from the ground up. So moving along. What are modules? Modules are a collection of files encapsulating functionality organized within a standardized directory structure. Modules can exist as source files within a directory or as a zip file with a .module file extension. Source files are typically what you're going to be looking at and editing while developing, while .module archives are built versions of the source module and used in deployments. Modules can do things like initialize data and data structure designs, provide custom web parts, serve HTML pages with custom CSS and scripts, supply SQL queries and R reports, and more. Modules are great because as they are a collection of files, you can leverage version control integration and all of the power and utility that that provides. Since the functionality comes in a bundle, you can also easily deploy the module between test, QA, and production servers without having to manually repeat various tasks. Additionally, since they're modular, you can have multiple custom modules enabled within one folder, or you can enable a certain module across 5 folders, or otherwise mix and match and reuse module functionality as necessary to compartmentalize different needs. Since module structure is standardized, you can take advantage of built-in capabilities using those structures. The features provided are powerful and flexible, so you don't have to reinvent wheels, but you can get the kind of wheel that you want. And for file-based modules, which is what we're covering today, a bonus benefit is that you often do not need to build and deploy to see your edits, as changes are picked up and applied on file save. So you just have to refresh a browser window. So what does a standardized structure look like? Something like this. Note that lowercase names are literals, while uppercase names are variable dependent on the individual module. Ellipses indicate that there are more files, file types, and functionalities that we've omitted for the scope of this presentation, but full docs will be linked to in our documentation slide for referencing afterwards. That will contain the gamut of possibilities and include examples. Source code modules live in the directory trunk, the root enlistments, server, modules, siblings to modules such as platform. As we're going to see, you can also nest modules a layer inside of other modules as well. Up here, we have files relating to build processes and general settings, such as the name of the overall module. These files can be really simple. In our demo today, none of these files are longer than 3 lines. Then, in the resources directory, you'll see a number of literal file directory names. Putting files in these folders will allow you to hook into the built-in capabilities of modules. For example, putting a .tsv in data will allow other structures to load in the data in the TSV into a list, data class, or other domain. If you don't put files in a bunch of these folders, or don't have some of these folders at all, you're also A-OK. Module functionality is modular, and you can opt in and opt out of built-in capabilities as you need. For example, if I didn't have this reports directory or anything inside of it, I would not have my R reports, but everything else would still work. So this map is for the source of a module. You'll remember that modules also exist in built.module archives, which have a slightly different structure as it's been compiled by the builds. Since we're generally going to be working with source files, we won't be looking at .module file anatomy today. So today, we are going to see and understand the functionalities of all of these directories under resources. And we're doing it right now. All right, so here we have the page for creating a new project on my server. I'm going to, for reasons that will become clear later, name this sourdough. Select the sourdough folder type, accepting other defaults. Alrighty, so here we are on the landing page. We're just seeing text right now, which is not super exciting, but welcome to our framing device, which is we're going to be looking at, within these tabs, the efforts of a hobbyist baker looking to perfect their sourdough loaf recipe. I'm going to initialize this folder and explain what that does later. Success, woohoo. For contrast purposes, let's look briefly at this entirely default collaboration type folder. You'll see it comes with a couple of empty web parts, but not too much else. By creating our sourdough module, our file-based module has set up a number of views and web parts and brought in a custom data entry form. We have also loaded in data, seen also here, pending our report generation and execution. We've also added a fun little icon up there. Woohoo. And yep, our module has also delineated an R report and executed custom LabKey SQL to give us a grid that we have applied metadata to. And additionally, our sourdough baker is putting together a website and so wants full page control. And here we have it. You'll notice that for the free tabs we just looked at, there's a pattern of demo to the left and the documentation to the right that points to the specific files you can reference in the sourdough module that are building this view. There are also more documentation links containing more explanation or further topics. The sourdough module is intended to be self-documenting, so it's easy to reference and also easy to grab and start modifying for your own means. So coming back to the overview tab, let's start looking through some code and shifting through how all of this actually hangs together. I'm gonna take a little sip. All right, so the thing to look at that's relevant is this right here. This is our file directory for sourdough. So starting from the top, we can see in the folder path up here that the sourdough module is in trunk, server, modules, and tutorial modules. It would work the same if sourdough wasn't inside of tutorial modules and just within the modules directory. Within the module, we have our free top-level configuration files. The properties of this module are straightforward. We name it and set the class as simple module. In our Gradle.properties, we are telling the builds harness to compile and put together this module from the source files. And finally, we are declaring a baseline dependency for a file-based module. One thing that's obvious is that our empty project did not have any upper tabs. And also, we selected the sourdough radio folder type option when making this project. These are both controlled by the contents within this folder type directory. Alrighty. As we can see, there are a number of folder tabs seen here. Excuse me. And each one has names and web parts that they are displaying. This XML is also controlling whether a web part renders to the main body or the right side of a page. And at the bottom here, we have some modules. This here means that by making a sourdough folder type, I am auto-turning on the sourdough module, and additionally specifying that the sourdough module cannot be turned off for this folder type. And the core module is enabled as well, but you are allowed to turn off core module features. There are a lot of options you can set within these XML files, and since we can't cover them all today, there's a link to our XML docs in our documentation slide at the end. And those docs are very helpful to reference while doing module dev. Remember that these built-in capabilities and structures of file-based modules are often optional, as I've mentioned before. You could not have this whole folder types directory, and the module would work just fine. It just wouldn't have tabs and its own defined folder type. Just gonna close these. All right. So one thing here is that I'm pointing to web parts using just a name. How does that work? Let's look at the views and web part tabs, daily log web parts. And I'm gonna reconfigure some files. Here's some bread to look at while I do that. All right. As we can see, there are free files forming the left-hand web part in HTML, a view.xml, and a webpart.xml. For context, let's see how this page's form actually operates from the UI level. All right, there is a third-party date picker package that helps out with the date. We'll choose today. I can specify a comment, and I can upload a file. And when I submit, a new line is added to our grid without refresh. Clearly, there also must be some styling to center divs and such too. If we look at the HTML for this page, we'll notice that there aren't body or head tags. This is because the entirety of this HTML will be rendered wrapped inside of the LabKey frame or page. All of this is functionally within the body. We'll notice that there's a script tag in the body as convention when a script writes page contents. We also have this empty div with an ID, myQWP. So how are these functions, such as init and onSubmit, getting pulled in? Well, I have modularized my JavaScript functions into their own file, but you can also choose to have your script functions defined right in this HTML file if you want, within the script tag, rather than what we are about to see. If we look at the view.xml, we can see that we're declaring some dependencies here. There are some to the date picker that we are using, loading both styling and scripts, and there are local dependencies. If we look at the scripts down in web, daily log scripts, we'll see that's within the web directory of our sourdough module, and it declares functions. One note is that I have opted for timeless vanilla JavaScript in these demos, but you do have access to jQuery as seen in the JavaScript console. We can use jQuery too, and the current version being pulled from jQuery. Major things to point out here is that we are executing a LabKey API call up here to render a new query web part to that empty div, the myQWP. We are specifying the schema and query name, the table for which contains data that got auto-loaded during our initialization button click. And we're also specifying some visual choices and sorting by the date column. We are using vanilla JavaScript to obtain the form field values and using another LabKey API call to insert the row into the list. Excuse me, just gonna take a little sip. Yeah, so we're inserting the row into the list, after which we refresh the grids. And the styling is pretty standard stuff. The final file to look at for this tab shows how we can call upon a web part with its name in the folder type.xml file. All right, here, we are saying that the title of this web part is daily log, which we can see aligns. Cool. Note that the webpart.xml file is not strictly necessary. If you want to define a web part, then you will need it. But if you just want the page view, you can just have the .html and .view.xml files. You'll also notice that I'm following some naming conventions over here. Daily log sides is the base name for all of the files related to rendering the right-hand documentation slides. These files will be quite similar to the files we just looked at, but lacked script and style imports. And within my web directory, pop that open. I organize my files by the base name the script and style files get imported by. Nice. So we have just covered views and web parts. Let's drive on to queries and reports. To remind ourselves, this is what the page looks like. As a plug, I highly recommend checking out our JavaScript docs if you want a good sense of what the LabKey API can do. One thing we could have done for this demo is use the LabKey API on this page to execute arbitrary LabKey SQL and do whatever with the data rows that come back. Display them, use them while executing another call. Lots of options out there that aren't in the scope of the demonstrative purposes of this demo. Alrighty though. First, while looking at this graph, let's cover where this data came from. One directory you may remember from the module anatomy slide is called domain templates. Let's close some of these. Here, we are describing the domain design of lists, sample types. We can describe the domain designs of lists, sample types, or data classes. I'm specifying a list template type named rises, and it has columns for the free lines in the graph that we saw and an x-axis. In this initial data section, we point to the file rises.csv, seen here. In case you're wondering, lookups do resolve by name for these .csvs, but you'll see there's no initial data file for daily log, which we saw in the views and web parts section. This is because, perhaps fortunately for many devs, you cannot put an image in a CSV. For more complex data initialization scenarios that are covered by a simple text.csv file, one pattern to follow can be seen here. All right, in the function upload daily log data, I'm calling insert rows with image files that point to files that are within my module. So also in the on-init, we are calling a function that that will create the domains that we just looked at in the XML that was specifying domain shapes. And we are saying to import the data as well. It's important to note that while I used an initialization button for clarity, it's possible to have a more invisible initialization. One simple idea is to have a list with a data row bit flipped to false, indicating not initialize. Once somebody lands on the main page of the folder, you can check via JavaScript against that bit that the folder is not initialized, run initialization functions, and then flip the bit to true for initialize so that you never even have to click a button. So now we have covered data loads for queries and reports. What about the actual graphs and grids? So let me set up some files again. Dashboard. Alrighty. And one more. Cool. So tabbing over. In this HTML file, we have a familiar init pattern. It calls the API function dashboards report.executes, which is pointed to schema lists, query rises, report name, rises graph. This corresponds to this file right here, which is placed in directories that are named in a manner that corresponds with expected structures. It's a pretty short function right here that just grabs data from the list that we have auto-loaded with data, and it plots some lines on a legend. Alrighty. And within the script, we use some JavaScript to grab the image that is returned, as well as the text output and display it. One thing you'll see is that we're rendering a query web part that points to the list we have auto-loaded data into, schema lists and query rises. But we're also pulling from schema lists and query rises query. This is actually a query that is defined within this custom module. Queries. Here we go. The SQL here is incredibly complex. Just kidding. This is a stand-in for whatever LabKey SQL you may want to execute. And the only differentiating thing here between the two grids is that I'm pulling in the x-axis for my query, which is auto-hidden in the base list. Similar to how you can apply metadata to a query on your server, you can specify a metadata file within your module as well. So here, I'm setting up conditional formats that apply some styling when the value of a cell is greater than 320. The way that this is done may look familiar. It's a XML file like the ones in the source XML metadata of a query and follows the same patterns. There are columns for which you can specify various properties. And here I'm just applying the same conditional format to all three. And thus, we finished the queries and reports section. There's more you can do too, as linked in the documentation sidebar, such as adding metadata to reports and specifying a query view within your custom module. We're going to move on to a brief pop into the styling and appearance section. The main things to note here is that there are no default frame to this web part, and the border is instead controlled via custom CSS. And if I click the link, you can see that we have full page styling control here. Nothing too special is going on here. We set up the same free files that we showed in the views and web parts section, HTML, view.xml, and webpart.xml. But this time we're specifying an XML attribute that removes the frame in one line, frame none in the view.xml. There are also some little styling toggles in here as well. I've set up files within the module to specify custom header and footer images. And if I click off to get remove that breads, and then on, we'll see some images pop up in the upper lower logo area and the bottom footer area. You can also use a custom module to specify a custom login page. If I've clicked this button and we've shown actual UI feedback patterns elsewhere, so we're just doing an alert for confirmation here, log out, and log back in, you can see I've slapped on a very simple background, but you do have full HTML control of this page. Alrighty, so now we are going to move away from demoing the file-based module itself and talk about some peripheral tooling that exists in LabKey to help out with dev. You can choose to use it or not. It's not necessary to the file-based module dev processes, but it can be helpful. So one tool that's available to you for updating your module without leaving the server is the module editor. It can be found by clicking, oop, my little dock is preventing, here we go. Developer links, module editor. In this upper dropdown, I can look for modules that are enabled in this server, in this folder. I'm going to look at sourdough. Alrighty, let's just pop that closed. So in the sidebar, we have a directory listing. Let's say I want to edit the HTML in my sourdough baker's custom website. I can go into views, noting that there are various directory operations I can do here, such as adding a new subfolder, deleting, adding a file. And I'm going to select my styling and appearances page. Here's the HTML. For just a quick visual difference, I'm actually going to edit the CSS and styling. We're going to make this red. Save changes. Alrighty, so now if I pop open my Chrome DevTools, which will disable the web cache, we can see the changes reflected. And for our eyes, just gonna change that back. And boom, there it is. All right. So one thing that's relevant to note is that not all files are capable of being hot reloaded, reflecting server changes on save. For example, if I look at the module.properties file, we can see that there's a banner informing us that the file is not dynamically reloadable, and so cannot be edited from within the module editor. Making changes within the module editor changes the source files of your module, so they don't get out of sync. The primary use of the module editor is regarding hot reloadable text files. You can edit query, SQL, and metadata, basically anything regarding views and more, but you can't say, look at image files in it. Cool. So now we've wrapped up the demo section of the presentation. As a reminder, all of the source code for the module will be publicly available. Do we have any questions?
Yeah, thank you, Rosalind. So while you switch context there, looking at the questions here, there's one kind of general question just while you were showing the code there for the various files, which editor you were using. So that's IntelliJ that Rosalind was showing there. That's kind of the editor that most, if not all, of the LabKey developers have been using for quite some time, for many years. It's just what we've settled on. Definitely not a requirement by any means for developing file-based modules or any other code in LabKey, but IntelliJ is the name of the one we use. There's another question here. Does the module editor do any validation to ensure that edits are valid for HTML, XML, JavaScript? No, I think Rosalind can correct me if I'm wrong, but the editor itself will not do any of those validations in the same way that something like IntelliJ or a different IDE would. The editor is just more of a text-based direct text area editor. When you go to your page and reload, you would see JavaScript errors or things like that in your console in that way. But that module editor is more of just kind of a quick way to make simple edits on servers or staging or test servers where you might not have your standard editor available. Another question, will the slides be available? So Rosalind will mention at the end of the talk here as well, how and where to find those slides and the resources to link to all the documentation for the things that were mentioned here. So one more question before we get back to the talk. Can any complex input form be developed without using Java code? So the definition of what you mean by complex there is interesting. You can definitely get pretty complex. So Rosalind showed an input form that does not use Java code to upload a file, attachment, to do a date picker. You could also do validation across your form inputs within JavaScript. So there's quite a bit of complexity you could do. So you mentioned a follow-up question for field level validation. There's several different ways of doing validation. Within the JavaScript itself, whether it's executing code on field blur or focus, things like that. There's also ways to, and I think it's mentioned in the more advanced topics, to do trigger scripts or things like that within the file-based module for different validation. So for further input on what exactly you might be asking, please feel free to reach out to us with more specific questions. But your field validation can get quite complex without having to go to a Java-based module. Please continue to type in questions along the way. I'll pass back to Rosalind here to go back over a few more slides.
Thanks. All right. So the next step is, here we go, to talk about the processes of deploying what you have built. We'll talk about cloud first and then on-prem. If you're hosted on cloud with us, you have a couple of options. One, you could keep your module in a repository on GitHub, and we then bake it into your distribution via TeamCity, our continuous integration and deployment tool. This is the most recommended choice, and it comes along with the benefits of version control. Coordinating with your account manager is a good idea to determine if this option is a good fit for you. Secondly, you can use the module loading UI, which allows you to stay within the server web page and upload modules as well as delete modules. This feature is compatible with servers running in production modes, not development modes, and some of the UI looks like this. You can see in the top image that you can create an empty module to load a .module archive into, and in the lower image that there's a link that allows you to actually load it in. So several of our clients use this method. A notable drawback, however, is that if you deploy a new instance, the modules do not persist. Only the file repository and the database are copied to the new instance. And since the modules are local to the original instance, they don't by default get carried over. Lastly, you have the option to send us the module that you have developed for us to load it onto your server. However, this takes work on the behalf of our DevOps team, and so does take up billing hours. Moving on to on-prem servers then. For on-premises servers, here's a workflow. The columns here are not options, but a progression of server types. We start with the dev server, where you're working on the module source files. Once you want to move on to QA or staging, you can then build the module with a deploy app or deploy module commands. This will package the module into the .module archive for you, which you can obtain from the path here. Noting that trunk is the location of your root LabKey enlistment, as we saw. Now that you have the .module, you want to deploy it to QA or staging. One route is to pop the .module archive into the trunk, build, deploy, external modules directory, where the server will automatically expand the .module into a directory with the same base name and load in the resources. Here, you can determine whether or not the module is ready for production. Lastly, it's of note that deploy app and deploy module by default create development builds. In order to create a production build, you can either deploy app with the following flag set, or you can go into the module.properties of the one or several modules that you want to be built and add the line build type production and then builds. Excuse me. So you will then have a production.module within the trunk build deploy modules directory, which you can use to deploy on the production server. To actually deploy on the production server, you can either use the module loading server UI we mentioned in the previous slides, or pull the .module into that trunk build deploy external modules directory. Lots of fun stuff. All right, now for our advanced topic slides. There are a handful of things that we did not cover within our sourdough module, so let's take a moment to cover what those are. So when we covered domain templates, those allow you to specify the design of domains. Assays are handled separately within file-based modules. There's a robust feature set here, and you can see some of the file structure here. Note that these are all nested under the assay directory under the top level module name. Many of these files are totally optional, but you can specify the design of domains, batch, run, results within your assay, add custom details views, associate query metadata, and customize batch safe behavior. By and large, though, the principal and most common use for the module assay directory is to define the fields on the domains. Next, we have ETLs, which allow you to extract data from a source database, transform it, and load it into a target database. ETL functionality can both be included in a custom module or written directly in the UI. ETLs can also either be standalone or run in a series of other ETLs in sequence. ETLs are pretty flexible and support diverse scenarios, such as migrating from one database schema to another, integrating data from multiple sources into a shared data warehouse, or logging/auditing details of repeated migrations or analysis processes. Next, we have trigger scripts. Trigger scripts are pretty fun. Corey alluded to them earlier in the Q&A section. These are scripts that are run when there is an insert, update, or delete event on a table. Here's a compatibility chart to look at while I talk. Trigger scripts are written in JavaScript, and you can hook into functions that happen before insert/update/deletes, or after insert/update/deletes, or on initialization before any rows are processed, or on complete after all rows are processed. Because you can invoke arbitrary JavaScript and have access to a LabKey API within trigger scripts, they are pretty powerful. You can use them for custom field validation, or altering the incoming data in some way, or populating another column, or sending out emails, etc. Finally, we have Java and React modules, whereas we've been talking about file-based modules so far. Java and React modules are not totally disparate. You can have a module that uses Java and React, or just React and no Java, or just Java and no React. So you have Java, React, Java, and React modules. It's possible to upgrade your file-based module into a Java or React module, or both, once you deem that it is necessary. Java modules are great when you need more power and customizability. You can implement your own API actions. You can create server actions and views, leverage the power of SQL scripts for database upgrades, and generally do many, many things. LabKey is largely built on Java modules, which should give you some idea of what is possible. React modules are modules that allow you to code with React. Using Gradle and Webpack, TypeScript, JavaScript, and style files are bundled and placed into the appropriate LabKey directory for web resources. The build also generates necessary LabKey HTML files alongside view.xml files. hot reloading is supported. So you just have to save and see your changes reflected if you're running in the appropriate modes. So if you put these together into a Java React module, you can make calls in your React front end to custom API actions that you've written in the server-side Java layer if you want. So please reach out to your account manager if you see if you want to see a tech talk on any of these topics, or if you're interested in a wholly different topic too. And that just about wraps our presentation for today. Here's the promised doc slide covering our topics for today. You'll be sent the contents of this via email later, but this is just to show the additional topics and the deeper walkthroughs that are available. Alrighty, thanks so much. Do we have any additional questions?
Excellent, thank you, Rosalind. There's one more question, and we'll see if some others trickle in here at the end as well. So one question that was just at the end of the demo question section was what LabKey entity you were using to put things in. I'm assuming by entity there, like data structure. So in this case, Rosalind, I believe is entirely using lists, so LabKey lists, just as a kind of general table structure for demo purposes here. But any of the file-based module functionality can be used, and we've seen used with other kind of more specific data structure types in LabKey. So be it study data sets or sample types, data classes, even custom schema tables to insert or query data from those that you might have. So yeah, so no restriction on what types of data structures you can use with the file-based module. It's often anything that you could have done through the UI in LabKey, creating as a developer your own SQL queries or wiki pages, things like that can be accessed and used. Another question that I've commonly heard related to file-based modules is kind of when looking at, if you want to pull up IntelliJ, maybe Rosalind, and pull up the R script that you had, kind of how do I get things right or line things up correctly so they attach to, while we're talking about data structures, attach to the right queries or tables when I'm using the file structure like this. So as kind of Rosalind mentioned at the beginning when going over the file module kind of structure file system, under resources there, if we look at this R report as an example, the kind of names of the subdirectories are very important and are mentioned in the docs page as well. So like under resources, there's the reports directory, followed by schemas, and then under schemas could be any of those top level LabKey data structure types. So lists here is the name of the schema that holds all the LabKey lists. There could be something there called study, samples, a few examples of different schemas. So anything as a developer, if you've seen our query schema browser, anything listed on the schema side of the tree there would fit into the file structure here. And then under that schemas list directory there, it says rises. So that's actually the table name that she wants to attach, in this case, this R script to. And likewise, that pattern follows up in the queries subdirectory, where again, you'll see lists, and then the file names there are specific new files or new SQL files that Rosalind is adding as part of this file-based module. But there's also ways to use the file-based module here to attach query XML to a built-in table or an existing table that might not be defined in the file module itself here. But that structure is also kind of governed by the names of those subfolders in the system here. So another question here is getting a new dev set up to work with LabKey modules can take a fair amount of work. Has anybody worked on making a LabKey dev container to speed up this process? I know we've definitely discussed it internally. I don't believe that one exists, that we provide yet. Somebody can correct me if I'm wrong on that. We've definitely tried our best to keep our documentation there's a setup dev developer machine page. I know there's all sorts of different trees within that for if you're setting up on a Mac versus a Windows machine or different database types and things like that. So yes, I agree. There's definitely several steps there. Hopefully our documentation is clear. If not, please let us know and we can update that. But no LabKey dev containers, so Docker kind of containers, I'm assuming is what's meant there. At this time, I believe there have been some clients that have done that themselves internally, just kind of with their own resources. I can reach out and follow up with the person that asked that question to see if we have any examples or can kind of connect people together to talk about how they've done that or where they've done that successfully in the past. And that's all the questions I am seeing. So thank you again, Rosalind. Again, as she mentioned, that the last slide you had on the docs links will be a good resource for this as well. Will from LabKey will be following up with those that registered for the webinar with the recording and links to the slide deck and other resources as well. If there's any additional questions that you have or come up, please feel free to reach out to us. We're happy to follow up offline and go from there. So thank you all for attending. Thank you, Rosalind. Have a great day.
Thank you, Corey. Thanks, everybody.